Magandang araw po sa lahat. Kami po ang Group 1 at ang topic po namin para sa ngayong araw ay traction power network. So, literally po yung presentation po namin ay umiikot lang sa traction power network. So, ano nga ba yung traction power network? Para saan nga ba 'to? Bakit kailangan nito? Anong kaibahan nito sa electrical power network na ginagamit sa commercial areas? Tsaka kung paano nga ba 'to nagsimula? Tsaka ano-ano nga ba yung mga bansa na merong traction power networks? So hindi na namin masyadong palalalim pa yung pagtalakay sa topic na to tulad ng electric traction, tsaka yung components at parts ng pag-electrify ng railway systems dahil yun yung i-report ng next groups. So i-expect po ninyo na napakaikli lang ng presentation po namin sa araw na to. Next slide. So yun nga po, yung outline ng presentation namin ngayon ay yung kung ano nga ba yung traction power network, yung history, applications, tsaka yung mga halimbawa ng mga bansa na merong traction power networks. Next. So ano nga ba yung traction power network? Basically, yung traction power network ay isang power grid. So familiar naman tayong lahat kung ano nga ba yung power grid. Base na rin sa mga discussion na natalakay natin with Sir Al. So yung power grid, yun yung 'di ba? Transmission line. Yun yung nagdi-distribute ng electricity mula sa power plant gamit yung towers tsaka yung connected ng wires papunta sa substation, papunta sa transformers at dinidistribute sa mga bawat bahay, bawat commercial areas. Yun. Pero yung kaibahan ng traction power network ay ito ay exclusive lang para sa mga railway systems na merong single phase AC electricity na merong lower frequency. So, bakit nga ba kailangan pang magtayo ng traction power network? Bakit nga ba hindi na lang gamitin yung national power grids natin? Kasi yung national power grids natin ay merong matataas na frequency, especially sa mga AC sa mga AC na electrical system. Yun. Kaya kailangan talagang magtayo pa ng exclusive lang na traction power networks para sa railways natin. So, yun nga, sabi ko kanina, para sa mga single-phase AC na merong mabababang frequency. Paano naman kung yung railway system natin merong DC na electrification system? So, yung sagot doon ay hindi na kailangan. Hindi na kailangan pa ng traction power networks kasi, di ba nga yung DC, wala naman siyang frequency. So, yung required na voltage or ng type ng current para sa isang DC train, kaya na yun ng mga substations natin ma-convert. So, posible naman kaya na yung ibang AC trains natin na hindi na rin magtayo ng traction power networks. Posible rin. Pero dapat yung tawag nito, yung type ng AC natin ay three-phase. Yun din, katulad din sa DC, kaya na rin ng mga substations natin na i-convert yung required voltage doon. Tapos, kung single phase naman, dapat lower frequency na rin siya. So yun, posible rin naman kung AC yung electrification system ng railway na hindi na magtayo ng traction power networks. So next slide. Yan, ito. Isa-specify na natin kung ano nga ba yung frequency na required ng mga AC trains natin na gumagamit ng traction power networks compared sa national power grids natin. So kung makikita ninyo, yung sa traction power frequency natin, meron lang itong 16, 23 at 25 Hz kumpara sa 50 at 60 Hz na ginagamit sa mga commercial areas, so yun sa mga national power grids na natin. So yun lang din naman yun. So in conclusion, yung dahilan lang din naman kung bakit merong traction power networks ay dahil lang naman sa required na low frequency ng AC trains natin sa mga railway system. Yun lang naman. Pero kung DC, yung trains natin, hindi na kailangan magtayo pa ng traction power networks dahil kaya naman yun ng mga substations natin. Yun lang po. Ngayon naman, ano naman po, tatalakayin naman po natin kung paano nga ba nagsimula yung traction power networks natin. Natatalakayin po ni Evan Cruz.
Mauna po si Gerald. Yung video ni Gerald.
pa ako dun sa iniwan ko sa'yo.
Alex, share screen ng video ni Jerel.
So, alam na natin na electric railways need a power supply that trains can access at all times. Pero we don't know how we reach the standardization of the power frequencies. Well, noong 19th century, napakaraming power frequencies na ginagamit. And yung very early isolated AC generating schemes ay gumagamit ng arbitrary frequencies, meaning random frequencies lang. And it is based on convenience for steam engine, water turbine, and electrical generator design. And yung frequencies na ginagamit nila sa mga systems nila ay nag-range from 16.7 Hz to 133.3 Hz. Next slide po. But things changed in 1895 when Westinghouse harnessed the power of Niagara Falls. So, nakakreate siya ng first generators that were 25 Hz. Pero initially, hindi siya 25 Hz. Professor George Forbes, a British consultant for the power company, recommended the use of 16.7 Hz because he was thinking na yung commuter type AC motors magiging commonplace. Pero si Westinghouse, ayaw niya na gumamit ng low frequency itong mga huge generators. He won't settle for any frequency na lower than 30 Hz. Pero yung problema dito, nakapili na sila ng speed ng turbine, which is 250 revolutions per minute. Pero 30 Hz cannot be generated at a speed of 250 revolutions per minute. That is why they settled for 25 Hz. Tapos, since itong Niagara project, naging influential siya on electric power system design, yung 25 Hz, nag-prevail siya as the North American standard for low-frequency AC.
So after nun, nagkaroon na ng standardization sa frequency. In the early days of electrification, so many frequencies were used to that no single value prevailed. London in 1918 had 10 different frequencies. As the 20th century continued, more power was produced at 60 Hz in North America, or 50 Hz in Europe and most of Asia. Standardization allowed international trade in electrical equipment much later. The use of standard frequency allowed interconnection of power grid. It was not until after the World War II, with the advent of affordable electrical consumer goods, that more uniform standards were enacted. Tapos sa United Kingdom, nagkaroon ng standard frequency declaration na 50 Hz as early as 1904. But significant development continued at other frequency. The implementation of national grid starting in 1926 compelled the standardization of frequencies among many interconnected electrical service providers. Yung 50 Hz standard was completely established siya after lang nung World War II. Parang doon na nag-base yung buong mundo sa 50 Hz. Pero not later pa after pa ng World War II. Next po. Yan. Other power frequency are still used in Germany, Australia, Switzerland, Sweden, and Norway. Use traction power networks for railways, distributing single-phase AC at 16 plus 2/3. 16 plus 2/3. Yes. 16 plus 2/3 hertz or 16.7 hertz. A frequency of 25 hertz is used in Austrian Mariazell Railway, as well as Amtrak and SEPTA traction power system in the United States. Other AC railway systems are energized at the local commercial power frequency, 50 hertz or 60 hertz. Yeah. That's the end of my report.
So good afternoon. Dumako naman tayo sa applications ng traction network or the traction power network, which these dedicated traction current lines are used when railways are supplied with low frequency alternating current, which is nabanggit ni Sandro earlier na magagamit lang itong traction network power pag mababa yung bigay o yung supplied na frequency AC doon sa from the national grid. Tapos, the traction current supply line is connected to substations along the line of the railway and usually runs separately from the overhead catenary wire na kung saan yung locomotives natin ay nakakakuha ng electricity. So bakit ano ba yung substation na binabanggit ni Sandro kanina at yung saan nakakonect yung traction current natin. So yung substation is the traction substation or traction current converter plant, which is nasabi nga ni Sandro kanina na siya yung nagko-convert nung mga electrical substation that convert electrical power from the form provided by the electrical power industry for public utility service to an appropriate voltage, current types and frequency to supply railways, trams, trolley buses with traction current. Ayun yung ginagawa ni substation na kung saan nakakonect yung ating traction power network. In countries in which the electric trains run with direct current or with single phase alternating current with the frequency of the general power grid, the required conversion of the current is performed in the substation. So earlier nabanggit din ni Sandro na pag yung ganitong yung mga gumagamit ng DC na electrified na hindi na kailangan ng traction power network kasi kaya na siyang i-convert nga ng natin substations na meron tayo. So the traction current supply lines are not usually laid parallel to the railway line. So parang ito yung natin, yung railway line natin, which is doon nagpi-fed or yun yung andoon mismo yung natin, national power grid line natin, andun yung catenary wire at andun yung locomotives natin. Hindi siya nakaparallel doon para nga in order to allow shorter line length and to avoid unnecessary influence to the electrical system near the railway lines. This is also applied to the current supply of some rapid transit or railways operating with alternating current in Germany. So nabanggit nga ni Evan kanina yung mga bansa which is mababanggit din sa next report na kung saan yung Germany isa doon sa yung may nag-operate nung meron itong traction power network. Tapos yung ito it is also possible then na i-layout yung traction current supply natin ng special cross beam right on the overhead wire, pylons above the catenary wire. So bale, sabi ni Sandro kasi nagsusupply nga siya ng matataas, tas ng malalaki na current, tapos mataas din kasi siya. So bale, pwede siyang ilagay yung natin, traction current supply natin or yung sa above the catenary wire na kung saan nandoon nga nakakonect yung pantograph, tapos siya yung mag-fed ng electricity doon sa locomotives natin. Tapos because the overhead line pylons have a smaller cross section than traction current supply mast, the cross beams cannot be too wide, so the standard arrangement of four conductor cables in one level cannot be used. And that's why mas okay siya na nakalagay doon, and hindi siya parallel para nga ma-achieve na hindi siya ganoon kahaba, same yung length, kasi kailangan nga ng mas shorter length yung natin, yung traction power network natin. So as a rule, traction current lines use single conductor. However, for the supply of railways with a high traffic, and particular for the supply of high-speed railway lines, two bundled conductor are used. So pag hindi mataas or hindi high traffic and yung supply ng high speed, in particular for the supply of high speed railway lines, gumagamit ng two bundled conductor. Pero pag normal naman is single line conductor lang yung ginagamit for the traction power network. Ayun po. Thank you. That's the end po ng application of traction power network.
Good afternoon, everyone. The next part of our presentation would be just about the countries with or are using traction power networks. First up in our list would be Austria. The Maria Zeller Railway in Lower Austria operates on a single-phase AC at a 25 Hz utility frequency. The railway has its own traction current lines with an operating voltage of 27 kilovolts. These lines are mounted on the pylons of the overhead wire over the catenary wire. Next up would be Germany. In Germany, single conductors are usually used for traction current lines, but for the ICE train, two bundled conductors are used. The traction current supply lines from the nuclear power station, Neckar-Westheim, to the traction current switching station at Neckar-Westheim, and from there to the Cardinal Central Station in Stuttgart and Sachsenhausen are implemented as a four-bundle conductor circuit. Thirdly is the Scandinavian countries. Excuse me. In Sweden, Norway, and some areas of the former German Democratic Republic, three-phase AC current is converted into single-phase AC current with a frequency of 16.7 cycles per second at the substations. Unlike in Germany, there are no dedicated power plants for railway electricity. All power comes from general electricity suppliers. Next would be South Africa. In the Republic of South Africa, there are extensive AC and DC traction schemes, including 5 kilovolts and 25 kilovolts AC single-phase systems. Electrification at Natal was stimulated by the takeover of the South African railway systems by the Electricity Supply Commission, now ESCOM, based on the Colenso Power Station. Last but not least would be the United Kingdom. In the United Kingdom, the Network Rail 750-volt DC electrification system in the southeast of England is supplied with power from an extensive 33 kilovolt power distribution network. And thank you for listening. That would conclude our group's report.
Ayan, Sandro, pa-end po ng recording. Okay.
Wala po bang audio?
That used the track to conduct power.
Meron na po.
Wait po. Ulitin ko po. Wait.
Hello, good afternoon po. I'm Judy Ansalonga. So, yung topic ng group namin, Group 2, is about railway electric traction. So, dito, i-describe namin yung various types ng locomotive and multiple units na ginagamit sa electrification system sa iba't ibang bansa. Next. So, ito yung outline ng topics namin ngayon. History, unit types, battery electric rail vehicles, and high-speed rail. So first, ang i-discuss ko ay tungkol sa history. So, railway electrification as a means of traction na ginagamit sa electric-powered rail vehicles ay nag-emerge at the end of 19th century. Although may mga experiments in electric rail that have been traced back to the mid-19th century or yung period from around 1830s to 1860s, mga ganon. And during this period, yung ibang major events in history, yun yung mga i-discuss ko. Next. So, in 1834, Thomas Davenport, who is from Vermont, constructed a circular model railroad that used the track to conduct powers. So, sa slide, makikita niyo yung illustration ng model train niya na to. So, yung paggamit ng electric motor para mag-propel ng small car around the circular track is considered as the first recorded instance of an electric railway. So, in 1839 naman, a Scottish inventor named Robert Davidson built the first known electric locomotive. So, pansin nyo, the earliest electric locomotives tend to be battery-powered, katulad ng invention ni Thomas Davenport. Okay, next. So, until dumating na yung 1880. So, Thomas Edison built a small electrical railway using a dynamo as the motor and the rails as the current carrying medium. So, the electric current flowed through the metal rim of otherwise wooden wheels being picked up via contact brushes. So Thomas Edison ran his test of the first electric railway in Menlo Park, New Jersey on May 13, 1880 na makita nyo sa picture sa right side ng slide. Okay. So to conclude, maraming na-offer na significant benefits ang electric traction compared sa predominant steam traction, particularly sa quick acceleration and power niya. Yan po ang end ng history. Thank you.
I'm Rose Aligar Pigesa, and I'll be discussing unit types. So there are three unit types: the DC traction unit, AC traction unit, and then multi-system units. And I'll be discussing the AC and DC. So DC traction units use direct current drawn from a conductor rail or an overhead wire. This supplies the vehicle in two different ways. Yun nga pong sa overhead wire and yung dun sa conductor rail. Sa conductor rail, yun po yung third or the fourth rail system operate at low voltages, which is 600 to 1200 voltage. And then the overhead rail system use the high voltage, which is 1500 to 3000 volts. Ito po yung makikita natin na nandiyan sa picture, which is the overhead wire, and this one is the pantograph naman po, which is ginagamit to harness the current. So these voltages are fed from substations. The substations po are located 3 to 5 kilometers for suburban services and 40 to 50 kilometers for mainline services. These substations receive power from electric power grids. And this DC traction unit is usually used for trolley buses and tramways. DC compound motors are used where regenerative braking is required. So, ano nga po yung regenerative braking? Regenerative braking is a way of taking the wasted energy from the process of slowing down a car and yung pag-slow down po nun is nakaka-create siya ng energy. I mean, yung train, pagka na-brake, syempre merong process of slowing down. May makakollect po tayong energy doon and it will be used to recharge the batteries. So next is the advantages of DC traction units. In case of heavy trains that require frequent and rapid accelerations, DC traction motors are better choice as compared to AC motors. DC train consumes less energy compared to AC unit for operating same service conditions. The equipment in DC traction system is less costly, lighter, and more efficient than AC traction system. Lastly, it causes no electrical interference with nearby communication lines. Some of this, I'll be discussing it later po pagka na-discuss ko na yung AC traction units. So despite all the advantages, of course, there will be disadvantages of using DC traction units. So DC electrical system necessitates AC to DC conversion. Gamit nga po yung substations na dapat ay relatively short distances to each other, since 3 to 5 kilometers na lang po. And this is the main disadvantage of DC traction system. So, what is a substation? A substation po is yung high electric system facility na ginagamit to switch generators, equipment, and circuits or lines in and out of the system. It is used, ginagamit din po siya para mag-change ng AC voltages from one level to another and to change all AC to DC and vice versa. And this is why the system is preferred only for suburban and road transport services wherein yung stops are frequent and also distance between stops is small. So the other one is the overhead wire or third rail must be relatively large and heavy. Next is voltage goes on decreasing with increase in length. So next is AC traction units. This draw alternating current from an overhead line. So isa po yun sa pinagkaiba nila ng DC traction units. Yung DC is there are two different ways while yung AC po is sa overhead line lang. And another thing is yung DC traction unit, yung engine that drives an AC main generator. It generates AC which generates AC current na nagre-rectify to DC by diodes that powers the DC traction motors. While yung sa AC naman po, nag-drive din siya ng same AC main generator which generates AC and the current rectified to DC by diodes. Nagkaiba lang po sila dun sa yung DC is converted to AC and yung AC na yun, magpapower siya sa AC traction motors. So, you might be wondering why the AC locomotives goes from AC to DC and back to AC. Ang answer po dun is, yung DC rectification, napaprovide siya ng clean current that the inverters can use to create the power na frequency needed by the traction motors. And the reason why the main generator is AC and not DC is kasi po yung DC generators are too large, too expensive, and too complex once horsepower climbs past 2,000 or so. So next is the advantages of AC traction units. So, fewer substations are required. Di po siya katulad nung sa DC na 3 to 5 kilometers lang. Ay, tama, 3 to 5 kilometers yung needed na distance ng substations. The next is lighter overhead current supply wire can be used. Reduced weight of support structure and reduced capital cost of electrification. And then for the disadvantages of AC, there will be a significant cost for electrification. And next is it also increases maintenance cost of lines. Overhead wires further limit panels. Upgrading needs additional costs, especially in case there are bridges and tunnels. Railway traction needs immune power with no cuts. So yun nga po, it will cost too much pagka mayroong bridges or tunnels na madadaanan yung truck natin and gagamit ka ng AC traction. So that's all. The multi-system will be discussed by the other member.
Good afternoon. Good afternoon, everyone. I am Mark Alinita Pasi, and I am here to report about the multi-system units. Multi-system units is also known as the composite system. Dahil sa usage of different variety of railway electrification system, nag-lead siya sa pag-create ng multi-system units in which it maximized the application of railway electrification system. Dahil gumagamit siya ng more than one electrification system. Ngayon, alamin naman natin kung ano ang multi-system units. The first one is the multi-system units is an electric locomotive which can operate using more than one railway electrification system. Sinasabi dito na ang multi-system units ay isang electric locomotive na kayang mag-operate under more than one railway electrification system. Ang electrification system ay mayroong tatlong parameters. Una, voltage. Pangalawa, current. Ito yung alternating current and direct current. Pangatlo, contact system. Ito naman yung overhead lines, third rail, and fourth rail. Yung tatlong parameters na ito ay kayang gamitin na multi-system units. Yung multi-system units is multi-system trains provide continuous journeys over routes which are electrified using more than one system. Kadalasang ginagamit ang multi-system units sa pag-provide ng continuous journeys such as crossing national boundaries and etc. Para ma-achieve yung paggamit ng more than one railway electrification system at pag-provide ng continuous journeys, kailangan ma-achieve yung two factors. The first one is changing locomotives at switching stations. Kinakailangan na ang train ay mag-arrive sa switching station at overhead wires na meron sila ay kayang mag-change ng one voltage to another. At ang locomotive na ginamit mo papunta sa switching station ay mapapalitan ng bago ka mag-depart sa switching stations. Ang advantages naman nito ay ma-achieve mo yung way for continuous journey at may prior stations ka for the change over ng locomotives ng trains. Pero, ang disadvantages nito ay may inconveniency at time-consuming dahil sa pag-change mo ng locomotives. Ang switching stations naman ay very costly to build and maintain. The second factor naman is it can operate under several different voltages and current types. Isang halimbawa na lang nito, locomotive mo na kayang mag-operate under 1,500 volts DC as well as in 25 kilovolts DC. May isang bansa yung nag-adapt sa paggamit ng several voltages at current types. Ito ay Europe. In Europe, it is common to use 4 system locomotives, 1.5 kilovolts DC, 3 kilovolts DC, 15 kilovolts at 16.7 Hz AC, and 25 kilovolts at 50 Hz AC. Noong early era na Europe, there is a consequent increase in the amount of cross-border traffics. And also, there is a rise of needs for multi-voltages locomotives. Kaya nag-come up sila ng solutions na kailangan nila mag-create ng locomotives na kung saan kaya niyang mag-operate under different electrification system. At ito ang nag-result sa 4 system locomotives nila ngayon. In overall, the multi-system units are basically or typically used for providing long journeys ahead, and it uses more than one railway electrification system. Yun lamang po, and thank you.
Good afternoon. I'm Chester Bolona, and I will be reporting in continuation to multiple system units, particularly in countries which are using this kind of system. First, let's discuss the difference between electrified third rail and overhead catenary line in terms of their advantages and disadvantages. So, electrified third rail's advantages includes 1. Third rail is cheap to construct. Number 2, it is easy to build. Number 3, simple to maintain. Number 4, efficient for low voltage systems. And number 5, good for short runs. So third rail is known for lesser complexities. That's why it has a lesser startup price, and it is easier to build in comparison to overhead catenary lines. However, it has disadvantages. In height, number 3, lower voltage input means lesser speed. So since ang DC ay meron lang lesser current or lesser voltages, then therefore its output would be the locomotive's output would be lesser in speed. Number 4, safety concerns on its low-lying nature. So of course, yung electrified third rails are in level with the rails, so there are possibilities, especially when it is exposed in the public. It can electrocute objects or people that may come across it. So yun yung mga there are safety concerns involving those matters. Next one, overhead catenary lines. Advantages. Number 1, it can run with either DC or AC power. So unlike third rail, which is only available to use in DC power, overhead catenary lines can run in either DC or AC power. Number 2 is compatible to higher voltages. So since AC current is known for higher voltages, so therefore it can operate in higher voltages. Number 3, higher voltages results to higher speed. So kumpara sa electrified third rail, it has a higher speed. So that's why mga high-speed trains operates under higher voltages or AC currents. Number 4, it transmits power over longer distances. So unlike sa third rail na inefficient siya in shorter distances because the distances becomes the resistance. Ayun yung disadvantages ng third rail. So inefficient siya sa longer distances because the longer the distance, the higher the resistance, the lower the voltage na nata-transmit sa locomotive. Number 5, preferable to use in longer distances and for heavy freight drag. So and lastly, number 6 is elevation from ground makes it safer. So yung overhead catenary lines ay dahil meron siyang it is situated on a higher or elevated distance from the ground. It is safer in public. And dahil nga ang overhead catenary lines ay nagtatransmit ng higher voltages, it should be situated on higher grounds para ma-avoid yung mga concerns involving yung mga objects na pwede niyang ma-electrocute or possibly yung mga humans na pwedeng makadaan dumaan or makadaan. Ayun, even with the advantages, overhead catenary lines has disadvantages too. Disadvantages involves high startup cost, its complexities, and number 3, high maintenance cost. So dahil sa complexities niya, unlike sa third rail which is lesser complex compared to overhead catenary lines, of course, ang startup cost or initial cost ng construction niya would be higher. And syempre, marami rin yung mga, and dahil mas maraming elements ang pinakonsider sa overhead catenary lines, maraming aspects ang pinakonsider sa overhead catenary lines, there is also a higher maintenance cost entangled with it. Number 4, less efficient in transmitting low voltages. So yan, proceed na sa countries and regions using multi-system units. First one, we have the Czech Republic and Slovakia, which operates at railways with both 3 kilovolts DC and 25 kilovolts AC, but without switching stations. These switching stations means interconnected portions of the utility system transmission network, and may include transformation between transmission network voltage levels. So of course, multi-system units involves it operates on varying voltages. So there is a need for switching stations which allows the train to adapt from lower voltages to higher voltages, vice versa. Next one, United Kingdom. The country started little by little in electrification, which initially was divided between third rail and overhead line. So just like every other countries, the United Kingdom has also started gradually in their electrification. And eventually, yung southern region ng UK was turned to 750 voltage DC system. And during 1930s, the electrification rose to 1,500 voltage DC between Liverpool Street and Shenfield and the Woodhead line. It was actually constructed after post-war. Post-war to natapos yung construction ng post-war natapos ng rise in electrification. And this was done when United Kingdom loan for an amount for development. Then next is on 1960s, West Coast Main Line adapted to 25 kilovolts AC overhead system. Next. Automatic power control. So this one refers to a system which was developed by United Kingdom that allows the train to automatically switch between voltage whilst moving. Then lastly, 1983, the London end of the London Tilbury and South End line was converted from 6.25 kilovolts to 25 kilovolts AC. Next one, United States. New Jersey Transit uses ALP-44 and ALP-46 locomotives for its Midtown direct service to New York. So ALP means American Locomotive Passenger, which was actually based on European, Swedish and German in particular, locomotive, but are meant to meet American standards or American regulations. So this one is the photo ALP-44. Yan yung example, yan yung itsura ng ALP-44, which is currently operating in New Jersey Transit. Next one, Amtrak uses AEM-7 and HHP-8 and Asala locomotive on the northeast corridor between Washington, D.C. and Boston. So yung AEM stands for Amtrak Electric Motor, and yung HHP is yung high horsepower. So yung numerical may sinisignify yung mga numerical values dito, which is yung 7 and 8. Ito yung horsepower on which the locomotive is operating. Yung AEM, which is operating on 7,000 horsepower, and yung HHP on 8,000 horsepower naman. Yung HHP is a type of this one. Yung HHP is on the right. This one on the right photo. Yung HHP is a twin cab. It's a type of twin cab electric locomotive manufactured by a consortium of Bombardier Transportation and Alstom for Amtrak and MARC. Next one. Italy and Spain. These two countries have similarities, so pinag-isa ko na lang din sila. Ito yan yung they have two systems supplied by overhead catenary lines, and they're operating on 3 kilovolts DC and 25 kilovolts AC, which are used on high-speed lines. Next one, India. India uses 1500 volts DC and 25 kilovolts AC for mainline trains. Mumbai uses 1500 volts overhead system. As of 2010 pa tayo itong 1500 volts overhead system. But actually there was a proposition that it will be increased to 25 kilovolts DC. 25 kilovolts DC, yan. Then, next one is yung Kolkata Metro, which uses 750 volts DC with a third rail to supply electricity to electric multiple units. Then lastly is yung South Africa, which has 15 kilometers of dual system track with both 3 kilovolts DC and 25 kilovolts AC.
Good afternoon, everyone. I am Aliyah Martinez from Group 2, and my topic is about overview on battery electric rail vehicles and high-speed rail. So starting off battery electric rail vehicles, a few battery electric rail cars and locomotives were used in the 20th century. But sabi nila generally, the use of battery power was not practical except in underground mining systems before. A bit of history. Battery electric rail vehicles were originally called as accumulator rail cars. Maraming bansa na yung nag-experiment for battery trains way back 1890 in Belgium, France, Germany, and Italy. Nag-try rin sila before ng iba-ibang batteries for trains such as nickel-iron battery sa US, nickel-zinc battery sa New Zealand, and lead-acid battery sa British Railways in Germany. Yung mga trains dito sa slide ay yung mga sikat na battery trains ngayon from first Alstom, then Wabtec, and Hitachi. And all of them now use lithium-ion batteries. So next slide. Ayan. By definition, battery electric multiple unit is an electrically driven multiple unit or rail car whose energy is derived from rechargeable batteries driving the traction motors. Prime advantages of these vehicles are they do not use fossil fuels such as coal or diesel fuel, emit no exhaust gases, and do not require the railway to have expensive infrastructure like electric ground rails or overhead catenary. On the downside naman is the weight of the batteries na mas nagpapabigat ng vehicle weight and their range before recharging of between 300 and 600 kilometers. As of now, mas mataas yung purchase price and running cost ng battery electric units compared sa petrol or diesel rail cars. Isa pang disadvantage is required ang one or more charging stations along sa route na nag-ooperate yung battery trains unless nag-ooperate yung trains as a mixture of electrified and unelectrified track. Kapag ganun kasi, na-charge naman yung batteries from the electrified track. So let's move on sa mga accomplishments by country na nagde-develop ng battery trains. First is yung Australia. The Byron Bay Train Service in Byron Bay, New South Wales is believed to be the world's first solar-powered train. Recently, in 2017 sa Australia, they have the Byron Bay Train, which is believed to be the world's first solar-powered train using a battery set para ma-store yung solar-generated energy from roof panels ng rail cars. Then, Austria. The Austrian Federal Railways has purchased 189 Siemens D0 ML trains from 2013 to 2020. One of these trains was converted to a battery electric multiple unit na equipped to operate with batteries and overhead wires. Nag-start yung test services nila last September 2019 lang. Next is Denmark. From the end of 2020, Stedler Flirt Aqua battery trains will be trialed on 2 lines. Kapag naging successful daw yung battery trains nila, they plan na maging fully operational yung battery trains and ma-replace the existing diesel trains by 2025. Next is yung France. In January 2021, Bombardier signed a new contract to retrofit and introduce a pre-series of 5 AGC battery-operated trains by 2023 in collaboration with SNCF in 5 French regions. Bale, Bombardier is owned by Alstom and will modify trains into battery trains as they opt to help na ma-decarbonize yung French rail transport. From dual mode na catenary and diesel-powered trains, ko-convert nila yung 5 AG series nila to dual mode battery-powered AGCs. And ang target ng French government in this project is to eliminate diesel trains by year 2035. Okay, next. Germany. In 1887, the first German accumulator rail cars were placed in service by the Royal Bavarian State Railways. So, sa Germany, meron na sila battery trains from pre-Second World War pa, which is yung DB class ETA na naging Nokia ETA in 1995. They also have the Stadler-Flirt Ako nga na project for 55 battery-powered multiple unit trains para ma-replace yung diesel multiple units nila sa non-electrified routes. Lastly, nasikat nilang model and latest model ng Germany is yung Siemens Plus D na mag-ooperate sa 2023 on electrified and unelectrified tracks. Next is Hungary. 50 battery electric trains will be gradually delivered from 2023 to 2029 for use on Hungary's railways. Sa Hungary, yung first batch of battery electric trains nila is mag-operate on both electrified overhead wire and non-electrified lines using battery power. Sa Georgia naman, the new Atos Cave Railway in Abkhazia in the country of Georgia, syempre, has 3 narrow gauge battery electric multiple units built by the railroad machinery plants of Riga in Latvia. Next, Ireland. Between 1932 and 1949 pa lang, 2 battery electric trains ran successfully between Dublin and Bray. So, ang latest naman sa Ireland is last 2019, nag-purchase sila ng 250 new carriages and kasama dito ang battery electric units. So, next slide. Japan. So, sa Japan, syempre di sila pauhuli with their 5 latest model ng battery electric trains. Last June 2020 lang, inintroduce na nila ang N700S bullet train and battery backup nila. Meron din silang NE train Smart Denchikun wherein nasa-charge yung batteries via pantograph. 2017, completely replaced na ng battery trains and diesel trains sa route ng Karasuyama line nila, where EVE301 series was implemented. And the last 2 are the BEC819 series and EV801 series nila. So, ayan yung pictures. Okay, last country is United Kingdom. Historically, a number of battery electric trains have been used on British railways na. Recently committed ang UK-based companies such as Hitachi, Viva Rail, and Bombardier na mag-produce ng battery electric trains in replacement ng mga existing units. Maraming models ng battery-powered trains ang UK such as Class 379 Electrostar na nag-develop ng brake regeneration, yung Class 77 Stedler without full line electrification, and Class 230 produced naman by Viva Rail. Ayan. The next 2 slides will be about battery electric trains produced by Wabtec naman, of the corporation, and Alstom. Ayan, next slide. Ayan. FLX drive battery locomotive. Wabtec Corporation is a manufacturer and freight company with over 150 years of experience in the rail industry. Looking ahead, the company has had the foresight to help bring in a new era of decarbonized locomotive transportation. Ayun. Ang goal ng Wabtec is ma-develop nga ang next generation of zero-emission locomotives while hoping na ma-adapt ito globally ng railway industry. Next is the Alstom's battery-powered train. Successful battery technology research project in cooperation with the Technical University of Berlin sets the course for alternative rail drive solutions. Alstom passenger trains will enter service in Baden-Württemberg and Bavaria in December 2021. So, itong last September 2021 lang, nag-conduct na ng technical demonstration ang battery-powered train ng Alstom and will be operational by this month of December. It will be the first battery-powered train approved for regular passenger sa Germany since 1960s. Okay, next. Last slide for battery electric trains. Ayan. According to Green Car reports, battery-powered electric trains will soon bring cleaner air, especially in Europe. Nare-reduce kasi ng example natin na Mirio Plus B, multiple units with battery hybrid drive ng Germany, ang real vehicle weight and na-improve din nila ang aerodynamics ng train. According sa studies ng Danish study last year, mas na-expose kasi ang passengers sa higher levels of harmful ultrafine particulates kapag nasa diesel train sila than electric trains or battery electric trains. Kaya, recommended na mapalitan ng electric trains ang mga diesel-powered trains. Kung mai-implement ito, lalo na ang battery electric trains, mas makakatipid pa tayo by reducing the reliance on the use of oil. Okay. The last part ng aming report ay ang high-speed rail na na-discuss na natin from the video na napanood. From, ano ba yun? World's Fastest Train. Okay. The TGV at 40. The new version of the iconic high-speed train is launching in an era of global rivalry. Babalikan lang natin yung recent update sa TGV and Shinkansen. Ayan, the new TGVM will use 1/5 less electricity than the current model while maintaining its top speed of 199 miles per hour. Recently, nag-celebrate ang TGV ng kanilang 40th anniversary and nag-launch sila ng modern TGV named as Avelia Horizon or this TGVM. Ang speed ng train na to will be the same sa top speed of this fourth generation ng TGV na 320 kilometers per hour but will now be able to carry 20% more passengers na from 600 people ay magiging 740 na yung passengers. Okay, next. The Shinkansen. And 700 Shinkansen high-speed railway line. Japan pioneered the use of high-speed railway lines by introducing bullet trains on the Tokaido Shinkansen line as early as 1964. 4 decades later, the country has an exemplary network of standard gauge high-speed lines and has introduced a new generation of trains and 700 Shinkansen to accelerate services to the next level. And 700 uses air springs in conjunction with a new form of automatic train control. Na-improve nila in 30% increase ang acceleration performance ng trains while reducing yung noise na nakakreate ng N700 for both passengers and surroundings. So, ayun. Japan presents N700 as significant development ng high-speed rail travel for its reduced energy consumption, greater acceleration, improved aerodynamics, and state-of-the-art tilting mechanism. So, ayun. That's the end of our report. Thank you very much.
Hello po, wait lang po kayo sa games. Ready na ba kayo? Like lang. Next na. Ano to? So, may mga jumbled words po. Tapos, paunahan lang kayo magko-comment. Okay, round 1. Paunahan lang Tongol. Tongol ang 1 point. Grabe, ang bilis. Next. Marto. Ang makabilis niya. Next. Sino? Wait lang. Sino? Alano.
Bea. Si Alano sa horsepower.
Tongol.
Alano.
Alano. Okay, next. Tongol. Ayan, tapos na
Uy,
pala.
all three si si Tongol, tsaka si Alano.
Okay po, tapos na. Mag-goodbye na po kami. Meron ba magte-take away? Mga gustong yumaman?